say.
That's awesome.
I
have to say,
I think I'll spare you all the indignity.
Oh, yeah.
I'm gonna sing it. Don't take this the wrong way, but A, I couldn't hit that note, and B, I don't see myself singing like that. So yesterday we looked at completing the square and how that informs us about the domain and range of a parabola. And we did a lot of practice just on completing the square. Yes?
No.
So hopefully you feel like we did that to death. There is a video for yesterday's lesson on the page. If you go to Thursday here, it says Thursday's class. This was all focused on completing the square. There's a little link there. You can click it and you go through it too. So if you missed it, that doesn't mean you need to feel like you've missed out. You'll note that there's also a blank copy of the note available there. So if you're at home and you don't have the note and you think, oh no, I missed my class, that's okay. You can get caught right up. Let's take a look at the bottom of lesson 1.3, at the end of that page. There'll be time. I'll give you this. Might as well just stick with us. Come to where we are, and then I'll give you this after. You can sit with it and copy it all out. So the function we've been given, I'm just rewriting it. I'm not changing it in any way here, is 4x squared plus 8x minus 9, right? That's in standard form. To know the domain and range of a parabola, I don't need it in standard form. I need it in what form? Vertex form. What technique do we use to put it into vertex form? Completing the square. Good. Now, the thing you'll notice here is that this question is one small step trickier because it doesn't start with an x squared like all of our examples yesterday. It starts with 4x squared. We're going to solve that by just factoring out the 4. We're just going to get rid of it first thing, and then we won't have to worry about it. Okay? So to do that, we would say h at x equals, what am I going to factor out? We always want to have just an x squared as the first line. So we're going to factor out 4. But again, remember that when we completed the square, we're not going to worry about the last number they gave us. We're going to use our own last number, right? That means we also don't have to worry about factoring that last number, which is nice because right now, what is that last number? -9. Does that factor nicely by 4? No. So we're just going to ignore it. We're not going to get rid of it. We're just going to leave it at the end and not do anything with it yet. So 4x squared divided by 4 would be? Yeah, good. So just x squared. And what does 8x become if we factor out a 4? Almost. We have 8x, we're factoring out 4. I don't know about squared. Yeah, plus 2x. We're just doing a greatest common factor here. And then remember, because we're going to do difference of squares, we're going to have to put our own last numbers here, right? So I'm just going to leave a space. Just going to leave that space. And then outside the bracket, what do I need to put? -9. Okay. Now, this obviously isn't a perfect square. If it were a perfect square, what number would be in there with it? Remember how we did that? There's a lot of these.
It would be a 1.
Then I gave you that homework, so you practice, which of course you all did.
It would be 1.
Good. It would be 1. How do you know that?
Because x is the big block and 2x is the little block. But that's how they say it. I'm sorry, I'm so used to the
That's fine. That's fine. That's a totally good answer. You're right. So you can picture it visually. Perfect. That's great. For those of us who did it yesterday, remember we said that we always got this number in the middle by doing what? Taking the number that's going to be on the end and double, right? Do you remember that? So the number on the end would be 1. And if I add a +1, I need to make sure I remember to subtract it. That's right. Good. What would I do from there? What would I do from there? what is this now? What can I do with that now? Remember from yesterday? Look at the side notes we did yesterday. Once we had it looking like that, what did this become? Just stream of words isn't helpful. Just need to make sure we all think through it. Nobody's going to do all the tests because you know the answer. You'll do all the tests because they know the answers. So yeah, what did we do here when we had x squared minus 10x and then we did the plus 25 minus 25? How did we get to that? Yeah, just put the 4 in front and open a bracket. So we're going to put the 4 in front, open a big bracket, and then just pretend it's not even there. And you can close the bracket at the end and put the negative 9. We're going to ignore all of that jazz. Just look at what's in the middle. Yeah, so again, I don't know where your kind of the work we did on the side yesterday was, but when we had that, what would we do with it now?
I'm trying to figure it out.
No problem. Do you have the
Yeah.
scrap paper work done yesterday?
Yeah.
Because if you get that and take a look at that, that might help you. You see? Okay, you're on the right track. I'm just trying to see if I factored up 4. This is good.
Yeah.
Now working with that.
This is what I did right now.
Perfect. So I'll just let you keep going, or do you have any questions? Are you a little lost?
I'm a little lost.
Okay, here's what I want you to do. I want you to pretend there's no 4 in front and pretend there's no 9 at the end. Would you know what to do then?
I think so.
Okay, so do that. So just completely ignore the 4 at the beginning, completely ignore the 9 at the end. Leave some space so you can put them in later, but just pretend they're not there. Okay? Now, I know you were away yesterday. That's okay. So I'll frankly just kind of have you follow along. Today's lesson's a quick one, and then I can sit down with you and go one-on-one.
Yeah, I'm sure once I go through the rest of it, I'll understand it more. Just
Yeah. Completing
tell
the
me.
completing the square is a grade 10 skill, and like just to show you, yesterday we spent all of this time just going through all these examples practicing to get there. So we just took some time to practice. So you missed that. So once you do that, you'll feel a lot better, I'm sure. Okay, Andrew, now that everyone's had some time, now is your moment to shine.
Right.
What would this end up becoming?
X plus 1
X plus 1,
squared.
X plus 1 squared. What did you get? Can I see?
I mean, I chose Andrew more than I chose.
Okay, so you've done everything right. The only thing you forgot is that yesterday when we did this bracket, we always did half of this number. Right? We divide it by 2. And again, we'll do some more practice later if we need it. We'll do 100 practices later if we need it. But you were right that what do I need to make sure I don't forget inside that bracket? So I've done the x squared plus 2x plus 1. That's x plus 1 squared. That's a perfect square. What do I need to make sure I don't lose? The minus 1. Right? Don't be sorry. I don't know who said sorry, but don't be sorry. All right, and now to answer this question, what would I have to do? Now to answer this question, what would I have to do? Does this look nice and clean, or is it a bit of a mess? No, don't be sorry, I got it. There you go. What should we do with this from here just to clean it up? Well, I've got like a small bracket inside a big bracket. That's a bit messy, right? Could we just multiply this whole thing out? So we would do 4 times x plus 1 squared, 4 times negative 1. And what would that work out to be? H at x equals 4x plus 1 squared. And then what's 4 times negative 1? Yep. Oh. Minus 4. And then, of course, we can't forget at the end, minus 9. We already used the minus 1. And then can we simplify that one last time? Yeah, what's negative 4 minus 9? No. No. Negative 13 is right. That's okay.
The form's not.
That's okay. Don't worry about it. X plus 1 squared minus 13. Okay. And now we factored 1 by completing the square. And that's a fairly tricky one. That one had a lot going on. We had to do a greatest common factor at the beginning to start with. Then we had to do the completing the square, then get to the end. That's about as tricky as they come, but that is an expectation for this course. Today, on the homework I've assigned, it includes a bunch of questions like this. I also put a link at the top of this video to a Khan Academy video on completing the square. So if you find my explaining it confusing, you can try that one out. See if that explanation works. That's a good thing, by the way. I'd suggest that if you do that, and if you practice a few of these, and you're still having trouble, come get some one-on-one help. Sometimes that's much more useful when the teacher can see the specific problems you're happening. I can also then show you kind of the manipulative method. You can work on the algebra tiles, bring that back, see if that from grade 10 helps you, so we can do some things like that. Don't be shy. You'll find a few times in this course we deal with the kind of content that you may need to come get some extra help with. I'm relatively unpopular with my peers, so I mostly spend lunch in here doing work. Sorry? Wow, I'm going to assume that was snarky and ignore it. I tend to get here about 7:15, so you can always come in before class. I tend to stay till about 3:30, so you can always come after class. So don't be shy. Once we have it in this form, now what do we know? What form is this? Yeah, well, you guys are so sleepy today. I know how you feel, but yeah. What's the vertex of this parabola? Yeah, negative 1 and negative 13. And does this open up or down? How do you know? You're right. Good. No, that's good. So this opens up, and we know where the vertex is. Could you tell me the domain and range of this, if we know that it goes up and that its vertex is there? Can anyone tell me the domain and the range? What's the domain of a parabola always? Domain are the allowable x values, right? What x values are allowed in a parabola? How many? All of them. How would I say that on here? Yeah, Andrew? Yeah, now not x equals, but x is, what symbol do we use? Yeah, and that means an element of or belongs to. And then how do I say the real numbers? Yeah, that's right, the doubled R. And what do we normally put that inside? Yeah, the brace brackets, the squiggly brackets. Okay, so that one's easy. What about the range? So a parabola either goes up or down forever, but it stops at a certain spot. What do we call that spot? The place where it turns around and starts going back the way it came? The vertex, good. So we know that y could be any real number. Y is an element of the real numbers. But in this case, this parabola that opens up and has a vertex at negative 113, what do I know about its y values? Sorry? Good. So it's got to be what? Bigger than or smaller than negative 13? Good. Well done. Well done. Good. All right. So that is the entirety of what we're doing with finding the vertex and explaining the domain and range of a parabola. Again, all the skills in there require a bit of practice. Make sure you go through, if you haven't already done page 31, number 1, and done all of those completing the square questions, do. Is anyone sure that they don't have a question from that now? From yesterday's homework, 31, number 1. You want to try one together? Let's see how we do. Or are we okay? Okay, good. We were on page 31, number 1. Let's pick one to try together. Are you groaning at me?
No.
Okay. Sounds a little like you are.
It's okay.
Okay, well, I'm sorry, whatever the reason is. Okay, let's do page 31. I'm doing this blind. Let's just do 1C. Okay, 1C. That is g at x equals, that's what? G at x equals
x squared minus 3x.
x squared minus 3x plus 1. Okay. So there's our function. When we're completing the square, what do we always do? You guys were on such a good roll yesterday. You were like rocking and rolling with these. I could hardly keep up.
Today is a new day.
I see that. It's almost like you guys have a case of the Fridays.
More or less not a little bit.
Does it feel like way more or way less? This week flew for me. So what we usually said was rewrite it and leave yourself a big space. Why do I leave this big space? What's this for?
The plus something minus something.
Good, that's right. Yeah, we have to make this a perfect square, right? How do we figure out what goes in these spaces again? I don't want the number. I want to know how we figure out what goes in those spaces. Also, no, I don't think so. No. Well, don't ask me. How did we get that number again? Yeah, we take this number and we do what with it? We divide it by 2. And when I do that, what do I get? Negative 1.5, okay. So do I do plus 1.5 minus 1.5? Is that the number I use? What do I have to do with it? I have to square it. What's 1.5 squared?
2.25.
Is it 2.25? Is that true? Yeah. So I would do plus 2.25, and then I would do minus 2.25. Does that make sense? Oh,
Wait,
did I screw up? I screw up a lot.
a negative.
It is, but when we square something, it
yeah.
is still
Never mind.
always. No, that's okay. This is good. It's a good moment. Why does the last number not matter that it's negative? Because what are we doing to the number anyway? We are true, but what else? Yep, we do add it and take it away, but also we got the number by doing what with that negative 1.5? Squaring it. And when we square anything, we get a positive number. That's right. So now that I've figured out what numbers we need there, now what do I know? Now how can I rewrite this? So we know that our number was negative 1.5, right? That's the number we used. What do I do with that now? Don't let it stress you out that it's got a decimal. We still know that this is a perfect square now, right? So how should it go in the bracket? I know, eventually the factor's bricks have to lead way to just the algebra. Does that screw you up? It's just you have to expand beyond it. You can do it. I have faith in you. I have faith. Do you not have faith? Okay. So in here we would do x, and then we would put our number, right? Minus 1.5. What do I need to make sure I do with that bracket? Square it. That takes care of those three terms. What's left over? Minus 2.25 plus 1. Good. Good. Those three terms make a perfect square. They go in here. And then these two terms remain. And finally, what can I do? What can I finally do at the end?
Plus 1 to so the 1.5.
Good. Positive or negative, so good. Does everyone see how I got those numbers? Here I took these two and just collected like terms. Are you cold again? I'm sorry. It's because what? It's not soup. Not soup. Yeah, it's not soup because you know what the weird thing is. You know what they call this? They call it sportswear, which is hilarious because can you imagine wearing ridiculous, right? But this is in like the 1950s. This is how you'd dress to go watch sports. You wouldn't wear a suit; you'd just wear a jacket. But it's not a suit unless what? Unless the jacket is made from the same fabric as the pants, which of course they would call like trousers or slacks, because these are old people. Yeah. So this is sportswear. I don't know why they call it these things. Okay, that's true. Does this make sense? Right? You still need some practice, I'm sure. There's homework from yesterday. There's some more homework on this today, just to refresh you. But if everyone's okay, I'm going to move on to today's stuff. And today's stuff is kind of refreshing. It's a lot more straightforward than this, which is nice. Any more questions from this? All right.
One thing I am doing.
I encourage it even. Okay, this is really Hey, here.
Yeah. Keep on breaking. Like my heart.
What? Is your heart breaking?
No, I don't know. I just like it's so worth it.
It's a little dark. But, you know, okay.
I think I got it in some
Okay. So today a relatively straightforward one. I will do my best to be nice and quick. I'll give you some time to work without listening to me talk. On radicals. Yeah, okay. So, that's true. So radicals are a special type of irrational number. Does anyone know what an irrational number is? I mean, I guess you must look on the sheet. What's an irrational number? Sorry? Okay. Anyone? Irrational number?
A number that cannot be written as
Yeah, a number that we can't write as a fraction. What's like the most famous irrational number? No, one is rational. One, I mean, any whole number, any integer is rational. Also rational, you can write as a half.
Okay, 0.9.
9/10.
0
Is
Negative.
rational. It could be negative. What's like the first really irrational number that you come across in math? It has to do with circles. What is it?
Pi.
Pi. Right?
Probably 5 degrees.
No, so this is completely true. That as far as we know, we have pi to millions of decimal places, and it never repeats. We've never found it to be a fraction. We believe, so, there's nobody who can do the whole thing. By definition,
Who
no.
puts it into the supercomputer so that you can do it?
Mathematicians. Mathematical modeling is a whole branch of mathematical research where they use computers to deal with big numbers. These are the same people using supercomputers to find really massive prime numbers with 52 digits. Yeah, well, it's not. It's actually essentially the opposite. Well, why do anything, right? I mean, we don't know why we do any of these things, but then technology becomes impossible without it. So one example that, oh, that's a highlighter. One example that we all know is pi. Pi is 3.14159265 blah, 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 blah. It just keeps going forever and ever and ever. And it can never be written as a fraction. It's what we call an irrational number.
Why is it irrational?
Irrational. Now, a radical is a special case of that. A radical is a number like that, an irrational number that is irrational because it's a square root. So it's anything that we take the square root of that isn't a perfect square. Right? So for example, square root of 2 is a radical. If you take the square root of 2 on your calculator, you won't get a nice decimal. Right? You don't get something nice. If you take the square root of 2, you get, you think I know this, but you get 1.414213562, and then your calculator stops. But if you put that, same stupid supercomputer that we're so unimpressed with on the job, it would keep going forever and ever. Decimals just keep going. It doesn't work like that.
Hey, sorry to interrupt.
Hi. No, it's fine.
You have another day.
Yeah. Dig in. All yours. So when we take the square root of something, it either works nicely, in which case we can write it not as a square root, right? Or it is what we call a radical, where we can't. So for example, the square root of 25. Is this a radical? No. Why?
Because it's 5.
Because it's 5. So this is not a radical. What about the square root of 7? What about the square root of 7? Can you take the square root of 7? Better than you go. See what you get. What'd you get? No problem. And does it keep going?
Yeah.
Yeah. So 2.645, and it keeps going and going and going. Your calculator will only take it so far, but again, if you put that lovely supercomputer on the job, we would see that this just goes on and on and on. The square root of 7 is radical. It's an irrational number. You can't express it just as a fraction. And then there's some that get a little bit, I was going to say sneaky. And I'll tell you what I mean by that. We could have something like the square root of 18. Now, can you take the square root of 18? Try it. See what happens. What do you get?
4.242640.
Okay, so it is definitely not a rational number, right? We get a big long decimal. But, and this is what today's lesson is about, could I write 18 as the product of two different numbers, multiply two numbers together to give us 18? What could I multiply?
9 times 2.
I could do 9 times 2.
18 times 2.
Or 18 times 1. 18 times 1 is not going to be helpful. 9 times 2 is interesting. What do you notice here?
9 times 2.
Yes? Now, can I take the square root of 2? Try it. See what you get. See if you get a nice number.
You just did it.
What'd you get?
You did.
What'd you get? Try it. See what you get.
1.42.
Does it just keep going? Yeah, it just keeps going. So we can't work with that. What about 9? Can I take the square root of 9? Sure, it's just 3 times 3. So here, We can't take the square root of the whole thing, but we can take the square root of part of it. Does that make sense? I can't take the square root of the 2, but I can take the square root of the 9. And the square root of 9 is what? 3. So this is the same thing as saying 3. And I want you to test that. On your calculator, I want you to take the square root of 18, what the number gives you, and then take 3 times the square root of 2. Confirm that. Make sure those are the same number. It's the same. Good. That's good, because if it wasn't, I would be screwed. I would have had no idea what to do. So I'm glad. All right, we call this a mixed radical, where we can take what's under that square root sign and factor it in such a way that we can bring part of it out from it. And the trick is we have to find a factor that is a perfect square. So let's take a look at example 1 below. And I gave you, I think, A, B, and C parts. Let's look at A, the square root of 50. What could I do with this? What could the square root of 50 become? Yeah, so sure. It could become the square root of 25 and 2. Actually, I'll keep writing below. That's nice. And what do you notice there? What can we do there? Yeah. No, it's okay. What were you going to say? Worst case scenario, you're horribly wrong. It is definitely still irrational. But can we work with one of these two? We definitely can't take the square root of 2. Can I take the square root of 25? Sure. What would I get if I did that? Good. So we can take the square root of 25 and bring that out in front. What would that leave me with? What's my next line going to look like? That's right. We're going to have 5 times the square root of 2, which is the same as the square root of 50. So this is a lot like putting a fraction in lowest terms. All 3 of these are correct answers. This bottom one would be considered the best of them. It's in its most reduced form. By the way, you have to be careful with these. You don't have to write this. Okay, what I'm about to put, it might be helpful if you didn't write. But instead of 25 times 2, what else could I have put under here? 10 and 5. Would that have led me anywhere? Would I be able to take the square root of either 10 or 5? No. So it's not necessarily the case that every way you factor it works. You have to try different ones until you find one that has a perfect square. So this one here, again, you don't necessarily have to draw this, though you may want to if it helps clear it up for you. Wouldn't work. We wouldn't be able to simplify that one. All right, let's see if you can try the next one without me. See if you can do the same thing. Break it into factors and see if you can take the square root of one of the 2 factors.
Yeah.
Good job. Well done. Yeah, so we can't just take the square root of the correct one. So here we say, okay, well, we can break this yeah, and find out about 2, right? And then even though we can't take the square root of 2, we can take the square root of 25, right? Are there 2 numbers we can break this into? Something times something? We have to find one of them that's a perfect square. So like it won't work as a you have to find like a whole number. 27 divided by 2, 27 divided by 3. Oh, we can do 9 times 3. Try that. I'll put that on the square. Let's see if that takes us out.
Yeah, I know.
So what are the only factors that we can make work for 27? 9 and 3. Is there anything else? I mean, 27 and 1, I guess, would be the other one, right? But that doesn't really help us much. So this is like the square root of 9 times 3. Can I do something with that? Is that useful? Why is that useful? What? Can I take the square root of 3? No. No, that doesn't work. Sorry? I can take the square root of 9. Very good. And what would my next line look like then? Yeah, 3 times the square root of 3. Good. Does that make sense? So we break the middle part up, and then we see if we can take the square root. By the way, we could keep trying to make sure that we didn't miss anything. Can we break 3 up into anything? No. So this one's done. The next one might take you a couple of steps. Or, if you're really good at your really big times tables, you might get it in 1. But if you're like me, it'll take you a couple of steps. Cassie, you try.
Oh, I just got this.
Oops. Yeah, it's easy. I'm impressed. My instinct is not to play for that time. My instinct is to go right to 9 times, which gives you 1 step, and then a few seconds after that's good. That's okay. But now, what can you do with 20? 20 is also your time. Okay, and that's good. Can you take the square root of either one of those? Okay, so that's up. That's okay. It is. No, you don't know what you need to get for this, and maybe I can have it. Honestly, so that's a perfect case in point where, actually, maybe I'll give all of you. Did I recycle all of these?
Maybe they won't tell me yeah. I mean,
Yeah, here we go. Very good. Okay. I'm 20 there. So this is like, so that's the factory? Good. Okay, let's take a look at C part. C part's tricky. This part is kind of sneaky. What could I break this down into?
4 times 45.
Okay, yeah, we could definitely do that. So we could say that this is the square root of 4 times 45. Did anyone do a different one? I'm going to show all the different ones we could do. What did you do? 9 and 20. Good. That was my instinct. To say 9 times 20. I don't want to show off with like an impressive one. Yeah, 5 times 36. Show off. All right. It's fine. It's fine. I want to do yours first because yours is, if you could get to this one, it's actually the easiest. Square in here. Very good. 36, which gives us 6. And so here we could just write 6 times the square root of 5. And can we go any further with that 5? 5's a prime, right? So we're done. So if you were clever enough to see that 180 is 5 times 36, nice one-step question for you. Great. If you're like me, I came to 9 and 20. What is this perfect square there? 9, okay. Oh, I'm so sad. Come on. Yeah, 9 is the perfect square. What would my next line look like then? 3 times the square root of 20. Now the problem there is, are we done? Or could we break 20 up into parts? What could 20 be? What could it be? 4 times 5. So this could be 3 times 4 times 5. And is one of those a perfect square? The 4 is, sure. Let's use a different color. Let's say green. And so what would my next line look like here? Well, it would be 2 times 3 times root 5, because that 4 is going to come out in front. And what's 2 times 3? 6. So we would get 6 times root 5. Is that the same answer? Sure it is. It's a trickier way of getting there, but it gives us the same answer. Does that make sense? So you need to keep checking each time you get an answer. What about 4 times 45? What's the perfect root here? Yeah, so what would I have below? Yeah, I would have 2 times the root of 45. And then what can we do with that 45? How do we get to 45? What is it? 5 times 9. Good. And is one of those a square root? 9 is, sure. And so what would that give us? 3. And so what would my next line read as? Yep. Yeah, and I'm going to break it down even further and say it'd be like 3 times 2 root 5, just to show where that 6 comes from. Though by all means, you could skip that step. That's okay. That's not a step I would expect you to show. I'm just showing it here to make sense of it, where we get it. It is, exactly. So do these 3 different paths make sense? Which one you go down doesn't matter. It's not the path you take that matters. It's the destination, but really it's the journey, right? 2 roads diverged into yellow wood, and sorry I could not travel them both in one traveler be. Long I stood and waited and looked down one. Anyway, I took the road less traveled. And that made all the difference. Anyone? No one? Okay, we'll move on. So if you left it here, you'd be halfway there. But this is not a wrong answer. You'd get some of the marks, but it's not a fully complete answer. It's important to answer fully completely. Does that make sense? Okay.
Fully complete square.
Wondering if somebody would get my tragically hip reference. Anyway, we'll move on. No, he just he came out on stage with Blue Rodeo the other night in Toronto. Yeah. Yeah, I don't think he's touring, but he came out for a song. Now, we're going to start working with these. Once we simplify them down, we can add or subtract radicals, and we treat it just like any other variable. What do we normally call the number out in front of a variable? Okay, what should we call the number in front of a variable? Coefficient, does that sound familiar? Yeah, so we have the coefficient and the radical. If this was 5x minus 3x, you'd know exactly how to do it. What would the answer be? 2x, right? You just collect like terms. Now, instead of x's, we have root 5s. But the principle holds. What's the answer going to be? 2 root 5. Yeah. If Johnny has 5 root 5s, and Tim beats him up in the schoolyard to steal 3 of his root 5s.
If he beat us up, why wouldn't he take all the root 5s?
Maybe he only wanted 3 of the root 5s. I don't know. You'd have to ask Timmy. The point being, Johnny has 2 root 5s left. Johnny, that's who. You got a problem with Timmy? Timmy will mess you up. Did you hear what he did to Johnny? He beat him up and took 3 of his root 5s. I wouldn't mess with him. So,
and it's the one recording, oh my god.
Nobody's going to continue.
What about here? If Timmy has 9 root 2s, and a math student who will remain unnamed and trash talked him is afraid of him, and in tribute offers him 2 root 2s so we won't beat him up after school, how many root 2s does Timmy have now? Good. 11 root 2s. That's straightforward stuff, yeah? Am I going to let it stay that easy?
Oh, you jerk.
No, I'm going to make it hard.
You didn't just have to do fractions, but you added fractions and other groups.
Yeah, no, this next one's hideous. It's hideous, it's ugly. It's awful, it's nasty, and it's so easy, you're gonna do
Do I have
great.
to answer in front, or root form, like an answer in number form?
No, we're gonna give it a precise root-based answer.
Okay, you do that.
Sorry?
You do that. LOL. Show us.
No, you're gonna tell me how to do it. Okay.
I don't.
Okay, look.
I think.
Are these all in the lowest terms they can be in?
Sure.
No, of course not.
No. So let's just break it down. Stick with 1/4, square root, and then what can we do with that 28? What could it become? So you've got your table of factors in front of you, by the way. That's useful. Find 28. How do we get 28? So we could do 14 and 2. Does 14 and 2 give us a perfect square to work with? No. Or we could do what? 7 and 4. Does that give us a perfect square? Great. So let's put that. 7 and 4. You don't have to do anything. Don't ever let anyone tell you otherwise. You're the boss of you, and I'm the boss of you and you. That's true. That's good. You can always play. Really, you guys are my boss.
They don't get paid. Taxes.
That's what I'm saying. Your
I
parents
don't
pay my
pay
taxes.
provincial taxes.
One day you'll pay taxes, maybe you don't yet, but you live in a home that pays property taxes, and there's lots of federal taxation that goes to provinces, even sales taxes, that gets funded down and transfers to the provinces, so you guys pay my wage. It's the very little bit of it. Your parents pay a little bit more. And I pay some of my own wage, which is weird. But anyway, 63, how do we get that?
9 and 7.
9 and 7, is one of those a perfect square?
9.
Good, so let's put those. And that's okay. It's not always going to work perfectly. What about 50? Can I make that simpler? 2 and 25? Good. The other option would have been what? 10 and 5. And does 10 and 5 give us a perfect square? No. So we like this one. Now let's just really quickly identify what the perfect square is in each case. What's the perfect square in the first one? 4. What's the perfect square in the second one? 9. And what's the perfect square in the third one? Okay. So let's do this. What is the square root of 4? 2. So I'm going to have what? 2 times 1/4. Then what? Yeah, square root of 7. Good job. What am I going to have next?
3.
Minus 3/4 times what? Well, I've been putting the number first, haven't I?
Yeah.
Okay, let's be consistent then. Minus 3, it doesn't. Multiplication order doesn't matter, right? So no, it doesn't make a difference. But 3 times 3/4, right? 2 times 8 is the same thing as 8 times 2. I promise it is. You're looking at me like you don't. That's okay. And what goes in the bracket? Yep, root 7. I said bracket, but you knew what I meant. And this last one, what should I put there? Plus 5 times 2/3 times root 2. Okay. Oh, come on, that wasn't so bad, was it? Well, let's talk about it. So now, what's 2 times 1/4? Yeah, both correct. Because of what the denominator is here, I'm going to stick with the quarters, but 1/2 is totally correct. You're right. You're totally right. So we're going to do 2/4 of root 7. And then what's 3 times 3/4? No, 3 times 3. You weren't kidding. I know, and that's okay. We all do it. But it's not 6, it's 9. Good. Minus 9/4, root 7. And then what do we have for this last one? Plus 10/3. You see, you say you hate fractions, but you got it totally right. That was the right answer.
There.
Which is fine. I don't know why we're also afraid of mistakes. My goodness.
Mistakes.
It looks bad on our final mark.
Sorry?
What happens when you get tortured?
Yeah, okay.
At school, you make a mistake.
When you.
Okay, well, I have yet to shoot at
mark
students.
down, you make a mistake,
I don't shoot.
why would you break it?
And what goes in the radical sign here? Good. Now, before we actually do it, can we collect all of these as one set of like terms?
No, you can do the 2 quarter 7, 9 quarter 7.
Yes, lots of numbers, but yes, you're right. These two have root 7s, so they are like terms. We can do math with that. What about this one? It has a root 2. Can we do any math with it? So we're going to have to leave it alone. That's how it is. Not ignoring it, we're writing it down, but we're not changing it. But what is 2 quarters minus 9 quarters? If a person who remains unnamed in the class has 2 quarters, and Timmy came up to him and said, I'm going to beat you up if you don't give me 9 quarters. 7 what? How many? Positive or negative? Negative. So somebody's got a problem because he's 7 quarters short.
2 quarters short, and then you got beat up, you got 3 quarters or 9 quarters in the first place. But probably you beat it like.
The date.
What's this?
Because in English, because now that he has a -7, that means the guy who stole him needs to pay it back. At least 7, so he has like. And then there's
How
a
you have
story.
negative quarters, okay? Explain to me.
Debt. You now owe him.
And
You're
then English,
indebted.
it's talking about this guy, Masumi, who owes this other guy
Oh,
dates.
then
Yeah.
There you go.
And I just made like a text to world connection.
Oh my God, did you just say text to world connection? Excuse me, I'm just going to go vomit a little over there, and then we'll get back to it. Wow. No, but that was a text to world connection. That's true. And I mean, my goodness, what a cross-curricular moment. And I feel like I did my best. You know, you mentioned like shooting you. My grade 9 science teacher was a terrifying guy named Pentland, Mr. Pentland. And the rumor was, and you later found out this wasn't true, but when you're in grade 9, you do pretty much anything, was that he'd been a sniper in Vietnam. But he was terrifying. So every day he would make you line up, he'd make you form a line at the door, and before you could go to your seat, you had to hand your homework into him. So he'd sit at his desk and you'd put your homework in front of him, and he'd put a little check next to your name and say thank you. And you did this every day. You walked in, you gave your homework, you went to your seat. And so the second day of class, I had done my homework hastily on the bus the day before, and I handed it to him and he said, well, this looks like garbage, I'm going to put it there. And he scrumpled it up and he threw it in the garbage, and they said, go to gray seats. And I kind of looked at him and he said, now. So I figured that meant I should leave. So I went outside and I had no idea what that meant. So I was just kind of looking around and feeling kind of nervous and awkward, only my second day of high school. And this janitor was walking by and said, until you go to the gray seats? I said, yeah. He said, go to the office. So I said, okay. And sure enough, I got to the office and there were gray seats there. And I went and sat down and the secretary went, didn't do your homework for Pentland? I went, no. She said, sit down. So I sat down. So, but he was amazing because he would sit in front of the class and he'd ask a question and he'd go like, it's 2 quarters times root 7 minus 9 quarters times root 7. And then you, of course, would go, thoughts? And he would proceed to just go to the class and shoot people until somebody got the right answer. It was very disturbing. I don't think you could get away with that anymore. I think in 2017 that'd be frowned upon. But, right? Yeah. Well, then it's just play dead.
Well, if you're gonna play guns, I'm gonna play dead.
No. All right. So,
Like, jump over the seat.
no, I'll tell you, you didn't mess around in his class. He was terrifying. I mean, he was great. He was a great teacher. I think he's probably a big part of why I'm a science teacher. But he was. Well, I'm a math teacher right now, but I'm really a science teacher. That's where my heart is. That's my love. What? Anyway, I mean, I like math too. I like math a lot. But what's that? Are you complaining?
No.
We'll move on.
She's
Okay.
not. She always yeah.
They're so little, they'd be so afraid.
Exactly.
They'd be so afraid. I will say, they all look like they could use, I just see them in the hall and I just think, somebody needs to be mean to you. Not too mean, but a little mean. So you learn that you can't just walk as a big group and you're just too nice at school. See, at some other schools, if they tried to do the thing where they walk really slowly in a big line, people would hit them. And then they'd learn to walk single file. But Eastdale, you're very nice here, and that's good. I'm glad you're nice to small little grade 9s, but maybe a little. That's all I'm saying.
Freshman time.
Anyway,
Look, I feel like
I feel like Trinity doesn't feel that way. Okay, so here's one thing I want you to. We're going to do an example here, but before we do that, I want to ask you a question. I haven't even asked it yet. God, give me a second, will you? Are these the same thing? Can I say this? Is the square root of 9 times the square root of 9 the same thing as the square root of 9 times 9? Why don't you check it? Why don't you test it? How could you test that?
I wouldn't do it.
Okay, well, hey, that sounds great. Let's see what happens.
You asked the world's
Wait, what? I don't think I did that.
Damn it.
Okay, I like that. What did you get? Yeah, what did you get? He's struggling. He's struggling with MathBot 6000 over here. Well, if we think about it, what's the square root of 9? What's the square root of 9? 3. And the square root of 9 again is 3. And 3 times 3 is 9. And 9 times 9 is 81. And the square root of that is 9. Yeah, so those are indeed the same. That's a principle that we're going to apply here. If we multiply a radical by a radical, we can actually write those as the product inside the radical. And that's helpful. That lets us get really clean math. Because, again, you don't have to write this yet. If I did root 5 times root 7, to be root 5 times root 7, that's pretty ugly, isn't it? It's not very nice. But because of what we just showed above, and you can test this on any 2 you like, I can show it as the root of 5 times 7. And if I can show it as the root of 5 times 7, then I can just call it the root of 5 times 7 is? What is it? 35. Good. This is a much nicer looking answer than that, isn't it?
No.
I mean, beauty is in the eye of the beholder. I'm not telling you what to think. I don't think you should have to subscribe to, society's sense of what is and isn't beautiful math, but I like that better. So, all of which is to say, when we multiply radicals, we can follow simple rules. Multiply the coefficients times each other, write that down. Multiply the numbers inside the radicals, and then simplify if you can simplify. Whoa! I don't know. I just don't know.
Why is there toes on the board? Aren't those toes?
I don't like it.
Oh, what? Yeah. Oh.
And then I flip on it.
I haven't yet this semester. I haven't had a good old explosion yet. Sorry? Did I? No. It's been a while. It's been a few years since I've had a good old fashioned snap.
We'll change that.
Sorry? No. So, not that I didn't want to. It just didn't come up. You have to feel like they kind of deserve it, right? So we can multiply the coefficients. What's 2 times 4? Yeah, that's 8. And then what's root 3 times root 2? Well, remember, we can multiply them together inside the radical. So we can call this root, which is? What's 3 times 2? Yeah. So we can call it root 6. 8 root 6.
Or the first time as we both mean that's the same.
8 root 6.
So you 3, 6, 2, 4, 6.
Why is there
The first one I need.
I'm not gonna lie, I don't know what you just said. So I can't tell you if it's correct or not. And I'm not saying that to be snarky, I just don't know. Does that feel common sense? Would you like one more really simple one before we do one that has the distributive property? Would that be helpful? Let's try this. Let's do 3 root 5 times times 2 root 10. I like this. Yeah, this is good. This is a good one because it'll get some simplification in there too. It is easy, I promise. Okay, well, that's because I lie a lot. Anyway.
No, what?
What would I get when I do this? 6 times the square root of 50. And of course, what can we do with the square root of 50? We can call it what? Yeah, we can call it 6 times the square root of 25 times 2.
Sorry for the interruption,
No, you're not.
teachers. Any students.
Which one of these can we take the square root of?
Bought tickets for next week's.
Okay, this is not going well. I'm not trying to be rude, whoever that is, but it's just not going well. What's
Any
just stop?
tickets for next week's semi-formal? Can you come to the cap?
What is cook? Well, I know. For like the first 3 seconds, I was just like static.
Okay, so what is this?
Any students who have purchased semi-formal tickets, could you please come down to the front foyer at this time? So those are students who have already purchased semi-formal tickets. Could you please come to the front foyer at this time? Thank you.
Don't leave me here. It's your mom. She can. She doesn't need to.
That's how I feel about that. All right, what's the square root of 25? And what's 5 times 6?
30.
Yeah, 30. So we would end up with 30 root 2. Does that make sense?
No.
No?
Just kidding.
That's not helpful, that kind of kidding. It's counterproductive kidding. So you know, if you're wondering.
Yeah.
Okay. Oh, I'm sorry. I'm not trying to rush. Okay, now when we have a number next to a bracket, what do we have to do? Yeah, we're going to multiply 100%. And how do I multiply something into a bracket? Like if these were x's, you'd know what to do. I'd distribute it. So I would do this times 1, and then I would do this times 3 root 6. So go ahead and do that. See what you get. First multiply it by the 1, and multiply it by the 3 root 6. Right? Okay, do you help or is it under? Okay, is it? Okay, fair enough. You're doing all right. Do you want me to go through it with you? And then this will be where we leave off for today, because the rest of the sheet will make good catch up on Monday. And this is more than enough for you to do your homework. Let's try this out. What is anything times 1? Just itself. So in this case, 2 root 3 times 1 will be 2 root 3. Does that make sense? That's the first step here. What's the second step we have to do? 2 root 3 times 3 root 6. So what do? We multiply the coefficients. Okay, what by what? 2 times 3, and that gives us 6. Does that make sense? 2 times 3 is 6. And then we multiply the radicals together. And in this case, what are the radicals? Good, and what's that give me? 18, is that comfortable? Does that make sense? Great. And now we just have to ask, can I simplify this? See, so 2 root 3, can we simplify that at all? I guess the answer is obviously no, because I just rewrote it. That was stupid. God, what do they pay me for? I'm doing my best. What about root 18? Can we simplify that? Obviously, yes, because I've left a big empty gap to 9 times 2. Good. And can we take the square root of one of those? 9. Yeah, we can take the square root of 9. So what will my next line look like? Equals what? Yeah, 2 square root of 3 plus what? 18 square root 2. Did I rush anyone by skipping a step there? Would it be helpful if I put the 3 in front? Do you get where the 18 comes from? Tell me if you don't. Okay, we're going to call it there for a day, because it's actually perfect. C, D, and E will be great practice when we come back on Monday, which will let us kind of segue into doing our homework. We have already gone through everything we need to go through. All the rest are just examples of the same thing. Okay? So I want you to make sure that you do the assigned homework. You know how the distributive property works. You know how the distributive property works. You know how to multiply things. And here's the deal. If you come to a question like that and you don't know how to do it, if you get trapped, move on. Right? Sure. Now, what I would say is this. I put today's homework. You'll need to add this. I added some stuff for completing the square practice and finding domain and range practice. So I feel like we need a bit more practice on that. Yeah? It'll be good for you. So go ahead and do that practice. Don't forget, at the top of the completing the square lesson, I added some links. One to Khan Academy, another to just the video of the lesson we did. Feel free to go through those. And, you don't hurt my feelings. Sometimes if hearing me explain it does nothing for you, and it just goes right over your head, and you go, oh my God, I don't understand what he's saying. You may find you go on Khan Academy, or you go on some other reference, and you hear it explained, and you go, wow, that makes perfect sense. Good, do that. That's good. Doesn't need to be me who makes sense. Obviously, I'd like to. My ego is more satiated if my teaching is clear and wonderful. But if a different source helps you understand something, use it. I will do my best to present those when people seem to be struggling with a certain topic. Right? And if you ever need more resources because you're having trouble understanding something I'm explaining, don't be shy. Ask.